We stand at a precipice. The next few years will be crucial in determining the trajectory of AI. A new species is about to emerge, the AI agent. First off, what is an agent? Well, an agent can perceive its environment, make decisions, and take actions to achieve specific goals. Basically, it can get stuff done in real life. Agency is the difference between a mere tool and an entity that can complete complex tasks on its own. Today's models have a glimmer of agency, but they are severely constrained by their environment. Text in and text out, they have no strong way of sensing the world or taking action. Models can provide instructions, but they can't reach a goal themselves. The agents you hear about today are either narrow or dumb. There are YouTube videos about how to build a narrow AI agent for some specific goal. That's fine and all, but that's not what we care about for this video. OpenAI Operator recently released, but in practical matters it's dumb as rocks, meaning it is clearly worse than humans at completing everyday tasks. However, this video will show why that won't be the case for long and why it matters more than you may realize. To understand the broader reality of AI, let's look at where we are on OpenAI's 5 levels of AI progress. Level 1 is conversational AI. At this level, computers can interact with people using natural language, for example, chatbots. Since ChatGPT launched, it's signed up over 180 million users. Millions of developers use OpenAI's API. LLMs have shown an impressive general understanding of human language. This is just the beginning. Level 2 is reasoning AI. This is where AI systems, reasoners, can perform basic problem-solving comparable to a human expert. The leap from level 1 to level 2 is substantial, marking a transition from limited capabilities to more human-like proficiency. The release of OpenAI O3 and DeepSeek R1 models show that high-level reasoning is very much a reality. These models are better at complex math and coding questions than the vast majority of humanity, and the IQs of these models are way higher than the human average. Level 3 is autonomous AI. At this level, AI systems, agents, can operate autonomously for extended periods. Today's general agents, by contrast, often break and require monitoring. True Level 3 AI would rarely break and could iterate instead of getting stuck. Basically, a good agent would be able to interact robustly and effectively with the real world. Level 4, innovators, and Level 5, organizations would constitute incredibly powerful AI systems. At Level 4, AI could revolutionize scientific discovery and technological innovation. Level 5 describes artificial general intelligence that could surpass human intelligence in every domain, potentially leading to a technological singularity with radically unpredictable consequences. AI would eventually gain all the power and steer the future of civilization. Hopefully the machine overlords will like us, right? I present these ideas because they show how important AI agency is. AI's interacting robustly and powerfully with the physical world is arguably the biggest remaining hurdle of uncertainty. If AI agents learn to apply their full intelligence to autonomously solving real-world problems, then levels 4 and 5 are inevitable. Succeeding at level 3 would provide the ground truth data to be profoundly innovative at level 4. Reaching level 5 would simply require scaling the number of these innovators. Also, there is a massive capabilities overhang. Basically, AI has incredible qualities that are not fully utilized. As mentioned earlier, these reasoning models are very smart. High IQ, good at math and science, above average at language. But that's not all. AI models can be replicated billions of times across data centers and run in parallel. Models can run at speeds much faster than the human brain, as neurons are intrinsically slower logic gates than transistors. Yet current AI agency is so limited that AI can't replace an intern. Imagine if AI was unhobbled and could exert its full intellect on the physical world. It all comes down to a data problem. AI has not yet been properly trained on completing real-world tasks, as there is no sufficient data set. But a powerful solution is on the horizon. Reinforcement learning is a powerful, flexible way for AIs to self-teach. In this approach, an AI attempts to complete a task, receives feedback, a reward, based on its performance, and gradually learns to improve its strategy over many iterations. You can think of this as the AI generating its own training data. For tasks where no human validation is required, the AI can gain experience very rapidly. However, unpredictable sub-goals may arise, making aligning these models to human values difficult. The shocking thing is that this mode of learning has no upper bound at the human level. Reinforcement learning leads to vastly superhuman ability in games like Go and chess. Will the same scaling happen in real life? Can an agent achieve 4,000 ELO in the game of making money online? Can a robot become superhuman at accumulating power and gathering resources? The answer is likely yes, and the timeline may be shorter than we think. But we haven't seen proof yet. That's the interesting thing about the next couple of years. If AI agents take off, the average person will come face to face with a terrifyingly real AI revolution. Alternatively, if agency proves unexpectedly hard, the AI hype train will hit a wall. Basically, the long-term trajectory of humanity will be revealed based on the next couple years of AI agent progress. There are two primary forms of agentic AI that are poised to reshape our world: robots and agent-computer interfaces, ACIs. Both leverage the intelligence of underlying AI models, but they interact with the world in different ways. Robots represent the physical embodiment of AI agency. They are agents that can directly manipulate the physical world, performing tasks ranging from manufacturing and logistics to household chores and even exploration. Several companies are aggressively ramping up robotics production, signaling a belief in the near-term potential of this technology. Training robots is inherently slower than training purely software-based agents. Real-world data collection happens in real time, constrained by the physical limitations of the robots and their environment. However, this data is invaluable because it's ground truth. It reflects the actual complexities and nuances of the physical world, which text data and simulations may struggle to fully capture. One advantage of physical robots is the ability to parallelize training. Multiple robots can operate simultaneously, collecting data and learning in diverse environments, significantly accelerating the learning process. This is analogous to having a large team of human workers gathering experience concurrently. A promising avenue for accelerating robot training is the use of virtual environments. Models can be trained in sophisticated simulations that mimic real-world physics and scenarios. This allows for rapid experimentation and learning without the risks and costs associated with physical deployment. The challenge lies in ensuring that the skills learned in simulation transfer effectively to the real world. There's ongoing research in sim-to-real transfer learning to bridge this gap. Researchers are developing techniques to make simulated training more realistic and to help robots generalize their knowledge from virtual environments to the complexities of the real world. It's important to note that robots do not need onboard computers to run AI models. They can instead connect to the internet and have their brain run in massive data centers. Therefore, progress in robotics is directly linked to progress in non-embodied AI. In this paradigm, robots can quickly switch to the latest and greatest AI model without any change to hardware. Alternatively, some applications may require low latency or the ability to function without internet connection. Small but powerful models like those from DeepSeek would be good candidates for this kind of local brain. Agent-computer interfaces, ACIs, are software agents that interact with the digital world through standard computer interfaces: a monitor, keyboard, and mouse. They see the screen and can generate mouse movements and keystrokes as outputs. This may seem less impressive than robots, but it's important to remember how much of our modern world is mediated through computers. ACIs can be trained much faster than robots. Their actions are purely digital, allowing for accelerated simulations and rapid iteration. They can perform thousands of actions in the time it takes a robot to perform one. Computers have saturated nearly every aspect of modern life. From online shopping and banking to research and communication, a vast amount of real-world tasks can be accomplished through a computer interface. ACIs can tap into this existing infrastructure, giving them immediate access to a wide range of potential applications. OpenAI Operator, while still dumb today, provides a glimpse into the potential of ACIs. It demonstrates the ability of an AI to perform basic tasks on a computer. Systems like Operator may simply need to be exposed to more data to become effective. In this way, these systems may become significantly more powerful over time. Imagine an ACI running and scaling an online business without human oversight. We can see that both robots and agent-computer interfaces are powerful avenues for agentic AI training. While robots offer the ability to directly impact the physical world, ACIs provide a faster path to agency by leveraging the vast digital infrastructure that already exists. As both types of agents mature, they may converge or evolve in surprising ways, leading to a future where AI seamlessly integrates into both our physical and digital realities. Will powerful AI agents really arise in the next 2 years? Seemingly yes. The stakes are high. Humanity's future hinges on the answer, and we're about to find out. The coming years will be a critical period of discovery, one that will determine whether the AI revolution leads to a new era of human flourishing or an uncertain future where we are no longer the architects of our destiny.